Yeah, okay. Yeah, okay, so now we are. Okay, so today's class, if you go to the Academy documentation, well, you'll see that we have been changing a little bit the structure, but if you go to weekly index, electronics design, week 6, there you scroll down a little bit, and you see FabLab BCM classes and KiCad 5. Okay, this is what we're gonna do today. Before we jump into that, I want to talk a little bit about what the purpose of the week is gonna be and the software tools that we're gonna use. So the idea is that this class is gonna be about electronics design software. And that means that you're gonna make your own boards, and that it's time for you to start designing and putting a little bit of brain into make new PCBs and not only reproduce them. For this, the normal software that we use is called EDA, or Electronics Design Automation, or Computer-Aided Design for Electronics. That basically helps us in that process. There are two main softwares, and you will hear these everywhere. One of them is Eagle. It was, I think, cool and well accepted until Autodesk bought it, and no one likes it anymore. And we don't use it in the Academy no longer. Now we use KiCad. Before we start into it, I want to talk a little bit about it. KiCad was part of a joint initiative by CERN and other research centers, in which they started thinking that it was not a good idea to leave electronic design software for private companies, so they made their own electronic design software, and here it is. Now we are in version 5. It's an open source cross-platform EDA with quite a lot of people behind it, and with quite a lot of features, actually. It's for a free, sorry? This KiCad.org or the other one? Yeah, no problem. Oh, yes, yes. Okay. And that. So you'll see that there's a lot of people behind it. Let me see, contribute about KiCad. So you'll see that, of course, there's a lot of corporations behind it, but here one of the biggest one is CERN. CERN is a research center that you might have heard of, that they have this Large Hadron Collider in Switzerland, Italy, etc. And they push a lot for making this happen. Also Raspberry Pi, Arduino, DigiKey, etc., etc., etc. So after this, again, this is a little bit like what Victor said in Blender class, and I think that gave a huge message. By choosing the tools that you use for designing, you also have a statement and you have a say in what you do. And it's important that we are conscious about the tools that we use. That's why we are using KiCad, and that's why we push for it and we try to improve it as well. Now, no more boring stuff. Let's jump into it. Let's talk a little bit about what the workflow of electronics design is. And I'm going to start with the complex one. The complex one is the industrial workflow. Okay, we don't talk about this much in the classes, but this is how normally you design a PCB. You start with a concept, basically some hand drawings. You don't jump directly into software. You start like putting some notes, thinking about it, looking for components, benchmarking, etc. You design it. The design process has 2 steps, as we will see today. The first one is the schematic. Schematic is just a sketch. It's like, let's say, an abstract representation of the circuit, the same way that we do it in the whiteboard with squiggles and wires and things like this. That is not the actual circuit, but resembles the functionality. After that, once we have a schematic, the same software, as we will see in KiCad, also has the possibility to make the PCB as it will look physically. Once we have all that designed, which I tell you is not an easy process, if you want to make complex PCBs, you prepare the files or you export the files so that you can send them to manufacturer. This is the same of all digital fabrication processes, right? So we do something in a computer, we prepare some files, we send it to a machine or someone that manufactures them. You do this in 3D printing, you do this in electronics, you'll do this in CNC, you'll do it everywhere. In this case, the important thing to know here is this name, Gerber. Gerber is the name that, or is the file format that has traditionally been used. And I don't expect you to remember it or use it yet, but it's good to know that when someone tells you, oh, I have some Gerber files, you know what they talk about. It's basically a file format used for fabrication in electronics. You send this to the manufacturer, they make it. As you saw with Edu, the processes or different processes for making a PCB. And then if you want, they can also assemble a PCB for you. In some cases, not only you have the, let's say the board, empty board, but you can also use a process called, or a machine called pick and place that basically puts the components on the board and then you put it in a reflow oven and basically the electronic boards is assembled. What we're gonna do in FA Academy is a little bit different. And you've already done half the process. What we do in the academy is basically, well, the first part is exactly the same. You see that the first concept and design part are exactly the same. We do hand sketch, we do a schematic, and then a PCB. And after that, it starts differentiating a little bit with the industrial processes. But at the end, it's the same. You prepare some files. In this case, you prepare a vector file, an SVG, that you have to convert into a normal, like a pixel image. You have done this already, so that you can fabricate it with a desktop CNC and then solder it and assemble. The main difference here is the preparation process. And the other parts, you already know how to do it. What we're going to focus in today is design and preparation. Okay? Do you have any questions so far? Is it all clear? And I think it's conceptually simple, right? So our software is, as we said, is the KiCad. You can check it on the official website. And let's get it started. The basic concepts that I'm gonna The basic concepts that I'm going to show are the same for every software. Basically, we have two areas, the schematic and the PCB. So we have two concepts to learn, symbols and footprints. What are symbols? Symbols look like this, and basically is the functional representation of the component. It seems a little bit like the component, but it's basically just a bunch of boxes with some wires and lines that like represent connectors. There are different types of symbols. You see some of them are very similar to what they actually represent. For instance, this display is an LED display in which you have the different connectors, and you already have here 1/8 that represents a little bit. And sometimes you have some things more complex that are like these MOSFET on the right side that honestly, I don't see that as a MOSFET only because I know, but the symbol representation that is what we have to remember, let's say. You see that the symbols have different legs, and different legs will go with wires to other components, and with that we'll make a circuit. Okay? Each symbol, at the end, since it's only a representation, an abstraction that we do of a component, is associated with what we call a footprint. And a footprint is, well, it looks like this, and is already a physical representation of the electronics part that we are going to put on the PCB, and basically is the projection or the footprint of that electronic component onto the PCB so that we can do the process called routing. What does it mean, routing? Routing is basically connecting the wires between each of the legs or each of the pins of microcontrollers or different electronic components between one another. As you can imagine, this is quite complex if you see it in this way, because all of a sudden you start getting circuits that look a little bit more like this. Let's see, that's a quick example. That you see things like this. And obviously the process here becomes really messy. It's not easy to see things here because this is how the electronics board is going to be. For that, that's why we have a schematic beforehand, to simplify our life, to make the connections in the schematic, and then have these connections transposed into a PCB design editor that even if it looks very complicated, it helps because we already have the connections defined, and the only thing that we have to do is route the wires. Here, you see that not only there are components, you also see some traces in different colors, and you might be wondering why there are some in red and some in green. Normally, PCBs don't only have one layer, they have two layers, and in this case, the red lines are what we call the front copper, so it's the layer that we see as if we were looking the PCB from above, and is the one that is nearest to us. And then the green one is behind. So it's like a projection of the back as if the board was transparent and we can see everything. You'll see that we'll be able to eliminate things and make things a little bit easier for visualization with different layers and stuff. Here as well, you also see these little dots, silver dots all around the PCB. Those are the vias. Probably, I think that you saw this with Edu. Those are the connectors from one layer to another. Basically, it's a little piece of copper that connects both sides. And other components that you see here, for instance, are the yellow parts that are pads. Basically, are things that you use either to solder things on top or to connect the PCB to a panel, like with some screws or things like this. And in blue, you see what is called the seal screen, which is basically the drawings that you put on the PCB that, for instance, show the logo of the company, for instance, open hardware, who did it, the revision, or the name of the component. Many people, what they do is put the reference. For instance, here I know that this is a resistor, and when I look at the bill of materials, this is resistor 12. I know what value of that resistor is, or other components for connectivity or things like this. But don't worry, we'll get to this. Anyway, conceptually, we see that doing up, here. So conceptually, we see that our process is going to go always through 2 steps, 2.5. But the first half of step is conceptualize, make some hand drawings on the piece of paper. The other steps are first, make a schematic. Second, make the PCB, the actual wiring. For this, we need two pieces of software that are separate. In KiCad, the first one is called eSchema. The other one for making the PCB is called PCB new. The workflow, we'll see it as it goes, but you have it here listed. Basically, you import all the symbols, you create the schematic, export the relationships to the PCB, make the PCB, and then export it for the machine, either with Gerber or with static images like PNGs. Here I leave this for reference. I'm not going to go into this, let's say, mess, but you can see here the different steps of the way in each of the process. It's quite simple if you think about these 2 parts, schematic and PCB. In blue schema, you can follow this like we did with flow diagrams in programming, and the same for PCB. So let's get started. First of all, well, let me refresh because I think we have changed something. If you don't have KiCad installed yet, please install it now. We're going to start using it. And also, if you can go to this page, go to the Getting the Libraries. I'll paste the link in the chat. I paste the link in the chat, and please download or go to the repository here, in which you will find the symbols and footprints that we use in the Fab Academy. This is the global repository of Fab Academy, and here you can simply download and put it somewhere with care. Let's say that it's not like on a hidden folder somewhere, that it's a place that you have under control and that you know where they are. Here we have the different libraries for symbols and for footprints that we need to import into KiCad. And why are they special? Because we normally, as we use a special process, let's say, with the PCBs and the desktop milling, we need specific footprints, and we also have a specific inventory, and it's a little bit like the Fab library that the whole community more or less maintains, okay? By the way, this guy, Chris Jennings, was a student here in Pablo, Barcelona, before, 1 year before, yeah. So what else? Let's open KiCad and let's get started. This class is going to be, well, we discussed, and it's going to be highly, like, besides this, it's going to be quite instructional. So either you follow the steps with me now, and Josep and Daphne are going to go through each of the tables and help you, or you watch the video later. Up to you. Okay, it's you can manage your pace, let's say. So I open KiCad. And as soon as it opens, if it opens. Okay. So, in principle, you shouldn't see the same image as I see here. The first landing for you should be empty. So what I'm gonna do is, are you still there? Or you want for me to wait for you to all see something like an empty page, let's say? Okay, a question before we start. Who is gonna follow like step by step with me, and who is just gonna listen? 3? The rest is not gonna follow? I'm just asking so that I see at least which people I have to pay attention if you are stuck and I can measure. Or if you guys want for me to wait or not. Please interrupt me if you have any doubt on either how to download it or where to download the Fab library. The Fab library is this link, and you go and download it here. Okay, well, installing the libraries, in principle, is just downloading them. So if you want as well, if you don't want to download it and you want to follow up with the updates, you can always clone it. You know already how to clone a repository, you know how to pull. So if you want as well, you can clone it either with SSH or HTTPS. and then you will keep up to date with the new changes that we make. This is not that frequent. You see that the latest commit was 10 months ago, but still every year we do a little bit when the Fab Academy goes. So if you want to clone it, and even if you want to contribute, that will be great. If you don't, just download. Okay. Giuseppe, si quieres, dime, tú que los ves, me dices cuando más o menos voy tirando para medir un poco. Okay. Hello. How are you? I'm good. Where was I? Okay. So once you open KiCad, you will see something like this. Either you have a project already working or not. Doesn't matter, the step is the same. If you want to create a new project, you just click on New Project on the top left. And it will ask where do you want to put the project in. I recommend that you don't save the project in, let's say, an open folder, that you create a dedicated folder for the project. Why? Because there are a lot of files associated with the project itself that are a lot of links, the schematic file, the PCB file, etc. That is going to go into the same folder. And if you put it on your desktop, all of a sudden you have 20 files. So it's better that you create a folder for it. So pretty simple, I create a class folder. I will put this in the documentation afterwards. Once we finish, I will upload it as a zip, and then you can download it as well if you want. So I create the folder, and here I also recommend that when you save the first time the project, you don't save it as untitled. Why? Because after that, it's going to be a little bit tricky to change the name of the project. So if you save it as something that you don't like, please think this step through and save it with a proper name, because we're going to generate so many files that sometimes you lose the connection if you just rename one of them. Okay? So the idea is that you just put something, I don't know, class example. Okay? This is the PRO or project file. It will define where all the dependencies for the project are. I save it, and here we are. You see that KiCad also already created 2 new files, class example SCH, schematic one, or the PCB. If we go into this folder, class, we see 3 files. One of them is the project file, the other one is schematic file, and the other one is KiCad PCB. I wouldn't recommend you to delete any of these, not even the project one or anything. And I would recommend that you create a separate folder for each project. Please don't make the same, don't put all the projects in the same folder, because it can get messy. And all of a sudden you don't know what dependencies are for which, okay? So now that we're here, everyone more or less okay? Please, the people, I don't see the people that are at home. So if you just can say something. Yes, you need to start a new project first. So, and for that, you click on the top left corner, create new project, and save it as I just said. People at home, if you don't mind, if you write something in the chat, also just say something on the microphone and I can check it out. Otherwise, probably I don't realize that you wrote something, okay? It doesn't bother me at all to be interrupted. Okay, Giuseppe, are we good? More or less? We wait a little bit? Okay. I'm going to do the same process as you, actually. And for this class example, I'm going to also download the FabLab repository. And I'm just going to, so that it all works the same way. So I'm going to save it. And once you have it here, I'm just going to put it on the desktop. Please, this one file that you download, put it somewhere that is like a nice place, not just somewhere in your desktop or a folder that you don't control. I don't know. It's quite important that you will reference them many times. So it's good to know where they are and that they are in like a nice place. Yeah.
Usually libraries, they depend on what, I mean, the library of the file library, we can use it even if we're using components outside of here, or how does it work?
Of course, yeah. So in here, something that I didn't say that was the next step is that you have libraries for the FabLab that have some components within that library. And also you have the official KiCad libraries that are symbol libraries and footprints. You have them here in these two links or repositories if you want. You can clone and then they will keep up to date. And a lot of people just create their own libraries. We won't see this today because it's going to be the introduction, but at some point we will see how to create our own components. And that means that you can create your own library. And you can imagine that a lot of people has created their own libraries and they are in GitHub or GitLab, etc. And at the end, it's a combination of all of them. I can pick the official KiCad symbol library with the Fab library, with something I created, with something someone else has created. And at the end, if everything is, let's say, nice and tidy, it all will work. Yeah. Libraries can be for the libraries as everything, let's say. We see this in Python, we see this in other programming languages. Libraries can be per project or can be global. I'm gonna give you the tip for a global library, but you can also have project libraries. Imagine that you have a specific component that you're only gonna use in one project. That is also a possibility, okay? Maestro? Vamos. Okay, so if we are in here already, then the first thing that we have to do is set up these libraries. We're gonna do this just one time, so don't suffer. It's gonna be only one time, it's one of these things, and then it will be done forever. So preferences, in my case, in your case might be different if you're using Windows or Linux, but there will be something like this. Look for preferences, preferencias, something like that. And manage symbol libraries first. You'll see something like this, and you see that there are two tabs, global libraries and project-specific libraries. This is what I just said, okay? We're gonna use global libraries. And in this case, you see, I don't know what you see in your case, but these are the symbol libraries from the KiCad library, all of them. And I have symbols for absolutely everything. From amplifier circuits to connectors to MCUs, drivers, etc., etc., etc. And you see that the list is quite large. Normally, libraries they end with .lib. You see this value here, this extension here, .lib. And here you can activate it or not.
They just download KiCad. They click on the symbol libraries. They are asked if they want to like copy something or start from zero. So here we have to tell them that use the second option, that it's
okay.
They create an empty symbol library.
Okay. Okay, so, well, I didn't know this because it has been a long time since I don't do this for the first time. But Giuseppe is saying that you have a prompt, is that right? That is either copy something or create an empty one. Create an empty one, okay? Create an empty one. If you copy something, it's gonna ask you to copy, I guess, that previous existing library because you are migrating or something like this, right? Okay, so create a new one. Okay, should I go on? So now, here you see that, for instance, I have one called Fab. This is the Fab library from the same one that we have just downloaded. I'm gonna add the same one, I'm just gonna change the name and we'll see how this looks, okay? So in order to to add them, you probably have different icons. Giuseppe, please check this process because I know that different icons and different versions of KiCad change how these look. But basically you have to look for something that says add existing library to table, which in my case looks like a little folder. In this case, you have like a Explorer window, let's say. And in this case, I'm gonna import the KiCad library, the Fab one. You see that the only option that I have is fab.lib to select. Make sure that you import the KiCad one. Probably you can also import the Eagle one. No, you cannot anymore. Before you were able to import it and then convert it. But now make sure that you select fab.lib, open, and it says, okay, add anyway. In my case, it says add anyway, you just add it and it will be the only one that you have. Okay. Here, you don't have to change anything else. I'm just doing this because I already have the Fab library, but I want to show you the process. You see here where the library is. If you want to delete it, you can just press this bin, or you could add them manually just by pressing this plus button here. Okay, are we good? Okay, so now that means that we have the FabLab symbol libraries. And we're gonna use just that one, but do you see the other ones as well, or not from the basic installation of KiCad?
No, porque si haciendo el copy te salían ya los símbolos.
Okay.
Como le he dicho,
okay, perfect. No pasa nada. Okay, so now, if you want, you can repeat the same process with the symbol library from KiCad. You can clone it, you can download it, and that way you import it the same way, and they will appear for you, okay? For now, we won't need them because we will use the Fab library. If you get out of the Fab Lab and you do electronics professionally, you can use the other, let's say, KiCad symbol libraries as well. But for now, in principle, the Fab libraries hook up with the whole inventory that we have. Okay? So before, all these steps as well are detailed here, importing libraries, etc. So in principle, you should be okay either watching this the class recording or following this tutorial. As well, I didn't say it, but KiCad docs and KiCad tutorial, you know, open source people like to document everything and to have very nice tutorials. So the documentation is not an exception. There's a lot of documentation about this, a lot of tutorials that you can watch as well or follow in text, and the links are in the documentation for the class, okay? So the next step is we're gonna import the footprint libraries. I already have the symbol library, so I just press OK. You can go to Preference and Manage Footprint Libraries. You see the same interface. It was not the same in previous version, now it is. You see that now the libraries don't end with .lib, but they end with .pretty. These are the symbols. And you'll see as well that they have a relationship. So symbols are associated with footprints. And if someone makes a library and the symbols and the footprints are not associated, you should blame them or just make an issue or tell them, because the idea is that it makes your life easier, not complicated for you, okay? So as well, I also have the Fab library in here. Sorry for that. Ah, just
Tarda bastante porque tienes todas las...
yeah, yeah.
Quiero hacer el check de los que tengas, pero mejor será más rápido para ello.
Se quedó beta. Okay, sorry for this. Okay. I come back. If you open the, well, you saw that I had to close because it was blocked or something. If this happens, you can open an existing project. You don't have to save it normally. Any action that you do is saved. And you go into class and you open the project, and here we are. Okay, so back to the point. Footprint library. Take it in here. It's gonna happen the same. Why did I do this? It was managed. Again, last time. Class preferences manage footprint library, sorry. Here we are, sorry, I pressed the wrong button. So here you have the same ones. You can add another one with the same procedure. Add existing library to table, open here. Well, in this case, it's asking me for permission, but after this, something like this will appear. And you can go to the folder that you want. And in this case, what you want is to select fab.pretty, the folder itself. You see that the folder is empty. Press OK. This won't happen to you because you don't have the same, the Fab library already added. And there you have it, okay? If you want to add other libraries, you can follow the same procedure. Once you're done, press OK, and we're ready to go. Okay? You good? No? Okay, should I go on or not yet? Yes? Okay, so now we're ready. It's time to open the schematic. So for open the schematic, you just click on this button, Schematic Layout Editor, and you see this first view is where the schematic of our project is going to be. Now, before we start putting things, I recommend that you plan a little bit and that you are tidy. It's very easy for this to become messy. I'm going to show you a way, or the way that I like to make schematics, which is like very OCD and tidy, but you can do however you want. What I recommend is that you divide your circuit in different parts and that you put it in boxes. But you can do as you like, okay? Here, a couple of things to check, or things that are good to have clicked, is on the left. This grid, it's nice to have it. Millimeters. And that's it. Josep, ¿podrías tener un ratón? Un ratón.
Sí, voy.
Okay, Josep is gonna come with a mouse, but still. You're all here already? You good? So we're gonna start making a small board. I'm gonna do just something that I'm just gonna make it up right now. It's not gonna be anything functional. Okay, perfect. So the first step is here on the right side, you see place symbol. You click on it and you see that nothing happens, but that the cursor becomes with this crosshair, let's say, that goes all over the screen. Wherever you click, this shouldn't happen. Don't worry, it's a mess that I have. It's gonna load the libraries and it's gonna open the list of all the symbols that you have. Here, I recommend that you, if you don't use all the libraries and you just want to use the fab one, it will be just like this. Once you get to know the names, you can start looking in here in this filter and type in something and it will search for you, okay? Here is the FabLab library. And I'm sorry for the names, but at the beginning you have to get used to it and you have to explore. Let's say, yeah. So you click, left click. Normal click. Yeah, or no? It doesn't appear this window? No? Debería ser, ¿no? Josep. Que no les aparece la ventanita de choose symbol cuando pones. Is this happening also to the rest or no? ¿Ah? ¿Todo bien? Ok, ¿qué pasaba?
No habían dado al botón de presionar.
Ah, okay. Okay, so sorry if I skimmed through this, but it's place symbol here, this symbol here, and then it becomes like this. When the crosshair is there, the crosshair is this, let's say, cross, is waiting for an action. So if you, whatever you click is what you are gonna open this panel. And what we are saying is that we are gonna place a component from the fab library. I'm just gonna choose any microcontroller. You will see that they normally start with add mega, which are the big chips that we have, add some, 80 tiny, etc. So I'm just gonna pick, I don't know, the 44, that is a very common microcontroller, and I press OK. Once I press OK, you see that I still have control on the symbol itself, and I can place it somewhere. Before you click, I'm gonna give you a couple of tips. If you press R, letter R for rotate, it will rotate. And you can, before placing it, you can rotate, you can change the orientation. Once you're happy with it, you just click and you place it. You see that still the crosshair is there. It's still waiting for something. That is because if we click again, then the same thing is going to come up. Okay, the choose symbol is going to come up. If you don't want to choose anything else, you just can press cancel and then escape. The way to get out of the crosshair is just press escape. Okay? You good? Do you all have a microcontroller? Doesn't matter which one? Good. Some things. With a simple symbol, things that you can do with it. When you hover, so when you put the mouse over the symbol, but you don't click it, you just put it on top, and then you press M, letter M for move. You somehow capture it, and you can start moving it. Okay? You see that this is a little bit like Blender somehow, in which you have a lot of keystrokes, and that things become very cryptic somehow. But it's just 4 that you have to remember. Is C, R, M, and G. What does, well, M we've already seen. R we already know as well. What does C do is for copy. So if I hover and I click C, I make a copy of the component. This is very useful, for instance, when you have to replicate, I don't know, 20 capacitors. And we'll see G afterwards, okay? Now, I'm gonna make a simple circuit on this, with this microcontroller that basically powers the microcontroller and has a button and an LED. For this, I need to input other components. And for this, I press, again, play symbol. The crosshair appears. I'm gonna put button. Button is normally called switch, 6mm switch here. Yeah. Sorry, I cannot.
How do you get the crosshairs to be stationary?
What does it mean, stationary? Okay, I keep going. You add the 6mm switch, okay. Here we see that it's like rotated by default, so I press R and I put it as I like it.
How do we delete
Delete it. There are 2 ways. You can, when you hover over the component and you press backspace, or if that doesn't happen because your keyboard doesn't work, then you just right click on it and delete. And it's gone, okay? Okay, so again, I press M and I move it around. The same for microcontroller. I just adapt this a little bit. Now I'm gonna add a couple of resistors, an LED, and a capacitor. We'll see why. Resistor. I still have done that. I'm gonna go to hub, and I'm gonna just put resistor. Okay, here you will be asking, which resistor do I pick? Well, when in doubt, the one that ends with fab. Why? Because it's the one that is, let's say, thought for the processes here, and is associated with a footprint that is like good for soldering by hand and also mailing it with machines. It doesn't really matter because we can change the footprint that we put with a symbol, but in principle, the default one is associated with a good footprint that is already good. Now, yes, exactly. That's where I was going to now. Here you see that in the symbol, I'm just going to place the fab one. And that in the schematic, it doesn't say the value of the resistor by default. It's actually empty. And the resistor that we put in here is a resistor that has a footprint but doesn't have a value. It's just a resistor. The same way that we could put a capacitor or a switch. The value, we put it ourselves. How do we put it? If you hover over, if you are over the component, you can either click properties, edit properties, and here you can change all these values. Or the fastest way is that when you are over the, for instance, R question mark, you press E, letter E for edit, and it opens that. And here you can just say, for instance, R1. Okay. And normally what I do is that this part here, the res, US 12, blah, 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 I just change it, and here I put the value, for instance, 10 kilo ohm. You can also put 10K ohm. If you want to put that omega is alt set, okay? And that way it's already defined only per value. Yeah.
Here, are you just rating kind of labeling it and giving it an ohm just for yourself so that you can connect with each other?
Exactly.
Telling the software that value, and then when it goes to this calculation,
No.
does the software simulate at all the electronics that will go on in the circuit? Just modeling.
As we're gonna do it, we're not gonna simulate. You can simulate it, but it's another process which goes into tools. I think it's either calculator tools. I haven't done it at all. And you have to simulate it. No, actually not. Our workflow is just for design, and the values that we pick in here are just for reference, either for us to pick them from the little boxes, or for when we put them into the fabrication files that then we send to the manufacturer, we have to explicitly tell them that component R1 is 10 kilo ohms. And for that, we either provide a CSV file with a bill of materials that they can relate to a component, and you just don't tell them that it's 10 kilo ohms, is that 10 kilo ohms from Panasonic resistors. But in no point we specify here the value as something that we're gonna simulate. We can simulate it, and again, I haven't done it, but if you go to KiCad tutorials, and if you want to get into this, here, SPICE and KiCad, or simulating KiCad schematics in SPICE. And you export the schematic, and it's a different piece of software that does it. But in principle, what we do here is just for our reference, but doesn't physically relate to anything that we can simulate at all. Okay. So I'm gonna keep going. I'm gonna add some components in, let's say, in batch, and then I'm gonna organize them, okay? So for this, I want to put a button so that I know that when I press a button, I can read it from the microcontroller, the same we did with the Arduino a couple of weeks back. And I want to also put an LED and some extra components. So I'm gonna ask you now, I'm just gonna put the LED, and I want to ask you what else should I put for that LED to work, if that's enough or not. Again, when in doubt, LED fab, that's the greatest, okay? So let's say I'm gonna just put this one here, and this one is gonna go with the switch. Do I need anything else with this LED or not? Just for components, not for wiring, just a matter of components. Oh, what? That's for wiring? This is an LED.
You need a resistor.
I need a resistor, exactly. So I'm gonna copy this resistor. Remember that the LEDs have a limitation in the amount of current that they can, let's say, hold or withstand. And we put a resistor to limit the current that goes through them so that they don't basically explode, okay? So I'm just gonna take this resistor here. I'm gonna copy it, and I'm gonna use it. You see that as soon as I copied this value change, R question mark, that's important because no component can have the same name in KiCad. So you couldn't have two R1s. If that happens, KiCad is gonna complain and it's gonna say, I have two of the same, which one is the good one, okay?
What was the first resistor for?
This is gonna be used for the switch, and this is gonna be used for the LED, okay? So I'm gonna just move them around a little bit. I'm gonna change the names. I like to put, I don't know, M1 here, and what color do you like the LED? Do you want it red, green, blue? Green? Good, green. Actually, it doesn't mean anything. It's the same as the value of the resistor. We will have to pick it afterwards, but for now, we know that this is a green LED, okay? You could also say here that this is, for instance, whatever you want, programmable. And I'm gonna add another one. Oh, by the way, so what I'm doing now is that I select something. Normal selection is as in every program. And then you right click, copy block. You go somewhere else, paste, okay? And that way you have the same structure again. This is useful if you want to replicate similar circuits all the time and things like this. So now I'm gonna put this one as green programmable, and this one I'm just gonna have an indicator for when I have my board connected. So normally I like those to be red. I'm gonna put red, power. And then I'm gonna call this M2. This one, since I already have R1, I'm gonna put this as R2, and then this one as R3. Okay. Before we go into, let me just change this one too. S1 and IC1. Okay. Before we go into starting wiring, I'm just gonna add two more components. Well, actually one more component and two symbols. These are gonna be for, let's say, I don't know if I don't expect you to remember, but we talked a little bit about capacitors 2 weeks ago, and that one of the purpose for the capacitors was to filter, let's say, the power input of our electronics. So it's very normal, and you'll see this, and you'll repeat it until you get bored. to add this circuit in the power input. You see here that you have VCC and ground. To add the circuit that I'm just going to show you, which basically adds a ceramic capacitor in the input. So I'm just going to go and add capacitor here. When in doubt, the fab one. Actually, better unpolarized. And here, this is not always the case. Be careful if you do these things, if you do these things outside of the academy with more complex electronics, but 1 microfarad is a good value for a filtering capacitor in the input of any microcontroller, okay? That is the normal. You would have to check the data sheet of the microcontroller or the component that you're using, but it's like a good normal value, okay? So this I'm gonna call C1, and now we're gonna start wiring, okay? So to wire things, we go to the right side and you see place wire. You click on it, and then again, the crosshair appears. And you see that the legs of the components have, let's say, this little circle around them. It means that I can connect something to them. So if I click on that, I can put already a wire, and I have this green line, let's say, that I can route it as I want. In this case, you can click and you see that it restricts a little bit how it goes. So I'm just gonna do and get to the LED. You see that the legs don't have this circle anymore. It means that there's something connected, okay? It disappeared. It doesn't mean that you cannot connect anything else on top. You can always connect more things there. But it means that at least that one leg is already taken by something. Now I'm gonna complete the circuit with the LED here, and I'm gonna go from ground and here, okay? I'm gonna also complete this part. If I click on a wire, while I'm placing a wire and I click on a wire, it will create a joint, let's say. And then I can go to the capacitor, and you see that it creates this little dot there. It signifies that there's actually a joint, and it's not just this. Okay, so that they are actually touching, and it's not a wire that is crossing. And the same for this one. So I go here and down. Now, in this case, I still don't have power input. I'm only connecting to the microcontroller, the LED, the resistor, and this capacitor. But I still don't have any power input from anywhere, okay? This is where what we call labels come in. And here you have to, yeah. Which lines? Exactly. Yes, there is a way. Normally, when you move, it's with M, but if you press G, you drag, and it stays attached. Yeah, G for the drag. Okay, and it moves. It doesn't move in the nicest way because it does this thing. You see that it doesn't look good. Let's say it doesn't. I like when they look like squared and nice, but they stay attached. Also, if you move it and imagine that you place it there and you see, oh, I lost these connections. You move it again and you place it in the spot and it takes them back. And then you can just do the dragging thing. You can do dragging with components and with cables. You see here, I'm dragging the cable and I can fix it now. And now it's all square and tidy as I like it. Okay, before putting labels and other components, we're gonna finish the other parts of the circuit. For this, let's see, I'm going to use, what do you think? PA2, this pin, PA211. I'm gonna use it to connect to the LED, okay? So I go PA2, I connect it here, then I follow the same step, and here, where do I connect? It's an open question. This part, the part that I'm waiting here, where does it go? It goes to ground, exactly. So I could just put it to here. You see, this is the ground pin. So I could just connect it here, and that would work. However, I don't like that because it makes the schematic a little untidy, let's say. If I start drawing wires here and there everywhere, it's becoming a little bit like not nice. So I'm not gonna do that. I'm going to delete this. And what I'm gonna do is introduce the concept of labels. On the right side here, you see that there's one A inside a little tag that says place global label. Labels are a way to connect parts of the schematic without actually having to draw a wire between them. So if I place a label and I put it here, and I say this is VCC, or better, 5 volts, put it in here, and I take that label and I put it here, I know that this and this part are connected, just by definition. So this label here and this are connected, and that way I can draw a wire from here to here, and I can draw a wire from, for instance, here to here, and this leg of this resistor, the label is here, this one on the right side is this little letter A. Yeah. And now, so when I place the label, now I know that this left label here, 5 volts, is connected to this right hand label here, okay? And you can make labels however you want, whatever name you want. The important thing is that they all share the same name for things that you want to connect. So I'm gonna add another one that I'm gonna call ground. So I place the same, the label. I put it in here. And I like normally to call this G and D. Okay? I place it. And another trick for your productivity, if you don't move the mouse and you press W, is wire. So you just can draw a wire directly from the spot that you are at. Be careful, because if you do it from here, you see it starts from there. So you want to go in the exact connector that you want to join. Okay? So now that I have this part, now I can start putting grounds wherever I want them. And the place that I want them now is here next to this resistor. So again, I copy the label, press W, I put it here, and now this is connected to ground. And it's much neater than the other way, okay? Are you still there? Are you okay? Yeah? Okay, let's finish this part. I want to have a pin in my microcontroller that tells me whenever someone has pressed the button, okay? In here I need, well, actually, I want someone that tells me more or less what to do. What do you think? How can I make, let's say, I'm gonna tell you that I need this switch and this resistor, but I would like someone to tell me, to direct me in which components or what wiring should I do. Let's say, what do you like, I don't know, PA7 as a pin? So we're gonna read with digital read the status of this switch with PA7. What should I do? Anyone?
Switch to A7, ground.
Okay. PA7. Here is the same.
Okay.
Okay. I normally like just to do this. It just looks neater for me, I don't know. But you can just do this, okay? This side, okay? I like to do the same also here. If it's symmetric, even better. Okay, so just before you continue, just look at this, right? So this explains a little bit what we're doing. Is just connecting pin 1 to pin 3 whenever we press the switch, okay? As simple as that. And now what else? Sorry, there. We need a ground. Where? Here or here? I'm gonna give you a hint. We need ground and 5 volts. I'm gonna just put it here. I'm just gonna copy what you think. Yeah. Let's think of what this resistor, of what do we want to do, right? When we press the button, how do we want the switch to be? Low or high? When we press the button, low or high? When we press it, we want 5. Okay, so where do I put 5 then? Up here? Here. Yes or no? No, I'm asking. I don't know. Below here. So I do this. Okay, and if and this one? On the top?
Like, shouldn't the ground come from the resistor then to the switch then to the side?
Tell me and we analyze what solution it is. So let's put it here, okay? And let's see what happens.
The ground to the top of the switch and then
The ground to the top of the switch.
no, the top of the switch. The top of the switch is a conductor, what I mean is the G. The conductor is like a G.
Mm-hmm. Yes, so no, here, there's no, this is just the top of the switch, let's say. Well, okay, I don't think this is gonna work, but let's see what happens here, okay? We try to, what is our purpose here? What we want to do is to determine unequivocally, I don't know, unequivocamente, like without a doubt, that there's the button pressed or not. If I don't press the button, here, I press the button and this is, we'll see this in inputs, or tomorrow actually, that this pin here is in what we call high impedance state, which means that it's just going to be, it's going to be sensitive to anything that happens around it. It's very sensitive. It's like, it's in one of these days that everything affects you, well, it's the same, you know? And when you set this pin as an input and you don't connect anything to it, it could be high or low by many reasons. It could be because someone touches with the finger, because there's electromagnetic interference around it, because the other pin is high, random things, okay? So we need to know, we need to have a way for it to be let's say, in a good position when the button is open. So here we already have a problem, okay? Once we have the buttons closed, what happens? We have, let's say, the pin connected to basically a wire, and here we have ground and 5 volts with a very large resistor. And there's not going to be a short because luckily we have that resistor, and this button is going to be to where it's easier, let's say, for the current to go, and it's going to be on ground. So that pin is going to be low. So we know that when we press the button, the pin is low. But when we don't press it, we don't know. So if we don't know, then it could be any situation, right? So, sorry? When we press the button, it goes through the easiest path and is low, or is ground. You see that here I use, let's say, indistinctively ground, low, 0, or false. They are all the same for us, okay? And it's always, we will see this tomorrow as well in the academy, but it's always this thing of binary, dual relationships, true or false, 5 volts or ground, high or low. This is always the same. Now, I think over there we had a solution for our problematic. What should I do with this? What does this mean? Sorry, which one? The ground should be here. So, okay, let's reason what happens here, no? I don't or tell me that, sorry, I cannot hear you properly, but do I do something here on the right side? Not sure? Okay, let's think through again. What happens here? I don't press the button, so I'm low. Good, I press the button, and compared to the situation before, I have the same situation. I just have ground and 5 volts here. Where does it, let's say, at which one is gonna go? To the easiest one, which is ground. So when I press the button, I have ground. When I don't press it, I have ground. So we have to change a little bit, okay? I'm gonna put this here. What should I change? I bring it here, like that. And this one here. Or no? I need to move the, okay. I'm just doing what you tell me, I don't know. I'm not expert in these things. So I need to move the resistor, okay. I put it in here. Oh, a trick I didn't tell you, but if you move a component with M and you put it in the middle of a wire, it cuts the wire, oh, not like that, sorry. If you put it on top of the wire, it cuts it and places the component in the middle. Just saves some time for you to delete wires and things like this. Let me just move this around a little bit. Okay, and ground, I move it in here, and I delete this. Okay, so what happens now? Now I have the input pin. When I don't press the button, let's say, the only path that I have to go is 5 volts. We have a resistor, okay, but remember that we're really sensitive today, and this is gonna drag us to high. Let's say these 5 volts, even if we have a resistor here, we are dragged to 5 volts. If we press the button, then we're gonna go directly to ground. And the path to ground is much easier than going to 5 volts. So now we know that if I don't press the button, I'm 5 volts. When I press the button, I'm 0 or ground, and that's good. I don't have any way out of this. Now, what we just explained here, this component, it has a name. Actually, this circuit, this thing here, you'll see it in many places. This is called a pull-up resistor. Why is it called like that? Because if you imagine this as a string, or like a spring, sorry, like a spring, it's like it's pulling the wire, or it's pulling the pin up to 5 volts, and that stabilizes, let's say, the reading of the pin, bringing it up to 5 volts, and always, whenever the button is not pressed, we are in 5 volts. So pull up resistor. If I'm just gonna ask you another question, and with this I stop bothering you, but what happens if I do this? Is this still valid? I just moved 5 and ground here. Does this work or no? Hands for no? Hands for yes? Hands for I don't know? Okay, there was a hand for yes over there. I want to know why. It's the same, actually, right? So let's think through. Here, if I don't press the button, what happens? I'm gonna pull down to ground. Remember, this pin is technically called high impedance. And not technically, it's very sensitive today. And it's gonna be pulled down to ground. If I press the button, the path to 5 volts is easy. And that way, even if I have this ground here, this resistor limits the current, and I have a direct path to 5. So I don't press the button, I'm low. I press the button, I'm high. It only changes the logic, but let's say the principle is the same. The resistor is exactly the same as the other one. This.
Wait, I don't understand. I'm thinking about like a flow. So I'm thinking like if you go from 6 to ground, you have to go through the resistor. And if you go from 6 to 5 volts, you don't.
Exactly.
And why is the resistor there in that case? Why do we need the resistor if we can go from 6 to 5 volts and nothing is going to change?
Okay, so let's imagine if the resistor is not there, okay? And then that way we'll solve the question. I'm just gonna move it away. I'm just gonna put it in here, and I'm just gonna make a wire. If the button is not pressed, we're good, right? We just have ground, perfect. But what happens if I press the button? I have 5 volts in the pin, but I also have them in ground. And that is called short circuit. So that's why we put the resistor in the middle, so that it limits the current that goes directly from 5 to ground. Yes, it's a short, but we have a resistor there. And okay, we're wasting some energy into the atmosphere, let's say, by just heating up a resistor, but at least we don't have a short and we don't burn our electronics. Yeah?
Okay, but it's not right?
I mean, it's necessary. It's a necessary evil, let's say.
It's not right that you're going to have a short here with this.
Exactly. Here, in this situation, if I press the button, I don't have a short. And that's why I put a value of a resistance value that is very high. It's 10 kilo ohms. Of order of magnitude, everything over kilo is very large. Everything below 100 starts to be complicated. You'll see that it warms up, let's say. I think what is probably confusing is that I'm doing the other way, and that you see that probably 5 volts would be above, but still the current can go from 5 volts to the pin or from ground to the pin. It's either way. The complicated thing here is that we never should connect ground and 5 volts together. Okay? Yes? Exactly, yes, we consume some current when the switch is off. Either way, that pin, some current is going to have to go into that pin. And then internally, since you have this high impedance state, means that there's actually here it was like, imagine that, sorry, inside the microcontroller, you have a very, very large resistor in that pin. And that makes it very sensitive. The current that you're going to have in combination of this resistor here that you have inside the microcontroller, that's the resistor that you activate when you say pin mode input. You activate that resistor, let's say, physically, plus this resistor here. The combination is so high that the current is going to be of the order of nanoamps, maybe. And it's, okay, there's some current, but it's very low. Yeah. It's some consumption that you have there, but it's so tiny that it's negligible, let's say. Yeah. Good. So now we have our very first circuit. Before we jump into the PCB and we're gonna take a break, just five minutes. But before we do that, I just want to do one thing with you. That is, these circuits, this is a very simple circuit, okay? It's not complicated at all, but you can imagine that things are gonna get complicated and it's not gonna be always so easy. I recommend one thing, that is you always use labels and that you compartmentalize a little bit. So I'm gonna do just that now. And I'm gonna take this part and I'm gonna move it over here. I'm gonna put a label here, and it's PA7. Okay. Put it there, copy, rotate, wire, boom, connected. Okay. The same for the LED. I'm gonna just take that one. It was in PA2, I think. PA2, wire. I remember to edit it. PA2, boom. See, rotate. I'm gonna just put it in here so that it's cleaner. Boom. Now I have an area that is just the button, an area that is just the LED. And I'm gonna do the same with this part. So I'm gonna I'm just going very fast, is because it's not a matter of what we do, but the principle. Sorry, let me just move this here. Boom, here, and okay. So now, sorry. Now, as you can see, I have a little nicer circuit, let's say. And if you are OCD as I am, then you can start drawing things around them and making like a nice little box. And drawing to finish it. And then you can even put a nice name, like MCU, microcontroller unit. You put it in there, boom, nice and tidy. The same here. Go here, you click on it, and drawing, place the text, power, bam. And the same for the rest. Now this schematic, it's a little bit more pleasant to see, and it's gonna be simpler for the future. Why? Because you go here and you say, okay, PA7, good. I go here, oh, this is connected to PA7, I just have a switch. I want to change something, I don't have to touch everything, I don't get into the risk of modifying something in the other areas. I have this very compartmentalized, it's nice and neat. And I don't say this because I want to be annoying, but if you go to any Adafruit, sorry. Sort of complex schematic. If you go to any, let's say, drawing that is somewhat complex or professional, you see these things. And you'll start getting used to it. You see that there's a microcontroller part. You see that there's a power and filtering part, USB and battery, a reset, and these are, let's say, small units of the circuit that first are much nicer, but that also if you want to have a look at this circuit, for instance, this is the Feather 32. Some of you already have some of these. You already can see very easily here what the circuit that regulates the power, how it does it go. So you have a diode, you have a capacitor, an input regulator. You'll get to see these components, but this way is a very simple generic standard circuit. You see that they also have the same reset button. They also have probably USB, an LED here. You see, we are making circuits at Adafruit level with an LED here and a resistor and ground. And the labels in this case are here, D13. I already know that this LED is connected to D13, that is here. Easy, okay? So that's what I'm trying to show you here, a little bit of so that is tidy and not messy. Yes. Sorry, it's impossible for me to hear.
Are we just filtering for electromagnetic?
No, well, there are several things, but here, normally, let me show you here. So if you imagine the voltage here, this could be, I'm not saying it is, but it's something like this. It's probably a little noisy. It's around 5, but it's not 5. It's 4.9, 5.1, etc. Normally, you want this to be a little bit more stable, and you put this capacitor here, so that it's like that. And that depends on your power supply. This could be, imagine that you have connected a motor there. A motor, like an electric motor, has a lot of inductance, and that generates a lot of noise. Also because you're actuating a motor, and that varies the load, and connecting one part with a motor with another part that has a microcontroller is not nice. So maybe you end up with something like this. Or imagine that on this side, you have a very sensitive sensor or a noise circuit that if you put a static noise in it, then it sounds bad. Then you want to put this component, which is, let's say, a capacitor, let's say a low pass filter, let's say that filters low frequency vibrations. This type of ripple that you see that is like higher frequency, you don't filter with a capacitor. We will see maybe tomorrow that you filter that with a component called Ferrite bit, and that filters high frequency. You will see this in a more advanced electronics that have very low noise requirements that are able to clean both. High frequency with the ferrita in Spanish, and it goes in series, and low frequency with the capacitor, but mostly it's for cleaning noise. Interference normally is not done with capacitor, but it's done with either Faraday cages or with big ground plates that make shields, let's say, that absorb that interference and don't go into the wire, okay? Clean, so now, I didn't say this, but you, at some point, it would have been nice to save, just in case. Save here, left, on top left, we save, and we come back at noon, and we restart, okay? We then jump into the footprint editor. Any questions yet? Sorry. Sorry? BCC. In this case, it's the same, yeah. It's just, I connected them directly, and in this case, would be the same.
why are they connected from both sides?
Well, it's just my way of doing it, but I could have done this delete C and that way. It's the same way. Why is this connected on both sides? Yeah, actually I could have, if it's easier, it could just be like that.
Okay.
It's the same.
And the same for ground, no?
And the same for ground, yeah. Actually, it's simpler. It's the only thing is that I copied from here, so I carried them, the wires, but it's the same. Yeah. See you. You had a question? No, please. She's done. Tell me. I come to you. Okay, 7 minutes and we're back. At home, is everything fine? Ivan, Kurt, Isabel, Tatiana, are you all good? You following? Please,
Yeah.
if I don't see the chat, just
Yes.
interrupt.
All is fine here.
So we come back in 5 minutes, okay? Let's take a little break.
Okay.
Okay, so we start again? Hello, are you there? Hello, hello. I see the remote people is much sharper than the ones here. Okay, so yeah, okay. So we finished the first part of the class with an schematic that basically is a representation of our circuit, okay? What we're gonna do now is start drawing some actual PCB and actual electronics that is, let's say, what we later on are going to fabricate. So for this, before we, we do anything, here you see that there's an icon that says net list. You have to click on this button in the schematic, and as it appears here, just the default one is the, let's say, the way to go. This is basically a file that we're gonna create in the project folder that defines the, let's say, relationship between our schematic and our PCB, okay? This is a normal procedure that we have to do in KiCad. You just click on net, the defaults are good, generate netlist. It will tell you where you want to save it, save, and that's it, easy peasy. Now, there are two ways for getting into the PCB editor from here. You can either click on this button, run PCB new on the top right, or you can go on the main window and click on this button here, the same one, PCB layout editor. I like to go from this button here, and here we are in the, let's say, layout for drawing our electronics. You see that it's empty, and this is because we have to load the file that we just created, the netlist. You can do it in previous versions of KiCad. You could only do it from here, so you have to click on the same button here that says net. You click here and select the file that you just created, open, takes a little maybe. Okay, and here it all should be in green. If it's not green, I'll show you how to fix it. We'll make, let's say, we'll see the situation now. But basically it gave us some info, let's say output, and it said, I'm adding symbol, okay? Okay, there? Yeah, so I started in here, and I clicked on net, okay? This generated the net list, and I saved it in the folder. Now I go to PCB editor, either from here, this button, or from the main window. And once you see the black background, you can click again on the same one, net, and you have it. There? You good now? You see the same as I see now? Not yet? Okay, it doesn't have this, but if you're clicking here, you just select the net file, open, and this should appear. This log in here should appear. Basically, it says that we're loading the information from the schematic into the PCB editor. Okay? No? More or less? Gonna check where Giuseppe is. Oh, he'll come back. Okay, please raise your hand if you, who has a problem here? You? Huh? You have 16 errors, okay. So I'm just gonna import them, and then we're gonna see what happens, what when we have errors, okay? Let's imagine that everything went well, and I say update PCB. Here, okay, I can click close, and you see here that I have, again, this crosshair and a bunch of, let's say, components that are all selected. I just click, and I place them wherever I want. If you zoom in, you see that they are all the components that I designed on the schematic, but they already have, let's say, the footprint with some white lines that, let's say, reference where connections go from and where they go to. Do you see this or no? Yes? Okay. You see that they have a very light color because they are all selected. If you click outside of them, they are deselected and they change color. ¿Puedes ayudar who has a problem here? Yeah. So here you see that we have these different components, and just one second, these little white hairs is how they are called, just represent the connections. They are not physical connections, but they just go, sorry, they just help us, you see? They move as I move the component around, and they just help us for us to draw the wiring, okay? Question? Yeah, so when you're here, you update PCB and then close. And once you close, you have the components. Let me delete this. Net, update PCB, close. And you see that this goes like this. Do you have no errors? They don't have the yellow one. Probably they picked another. It doesn't matter if you see a different footprint than me for the microcontroller. Probably you just picked a different one. What it matters here is not the footprint itself, is that we see some components there. Good? Okay. So now when you're here, you have all the components. And how do I know that I have all the components that I imported from the schematic? Because here I don't have any error. Okay, if I had an error here in red, it will tell me, hey, this component doesn't have a footprint. I don't know what to put in here, okay? So let's see if that happens. Imagine that I take this microcontroller here in the schematic. I press edit, and you see here that there's a field that says footprint. I'm gonna delete it, okay? I'm just gonna leave this component without a footprint. This means that this symbol doesn't have an association for later on into the netlist. So now that I've already built the netlist, I don't have to rebuild it every time. I just can go to PCB new and then click here, update PCB from a schematic. Boom, error. Okay, this tells me there's no footprint assigned for microcontroller 1. I cannot put anything here. If you press update, here, be careful because there are some checks up here. And if you read, it says update footprints. If I change the footprint in the schematic, should I change it? Yes or no? Delete extra footprint. If I remove the footprint from the schematic, should I also remove it from the PCB? Yes or no? Delete single path nets means if there's only one wire floating somewhere that is not connecting to anything, should I remove it or not? In this case, if I delete these extra footprints and I say update PCB, the footprint that I had from before is not going to be added, and it's not going to change anything. And to fix this, I have to go into here and add the footprint back again. Now, you don't have to know the footprint just by yourself, but you can press in this library here, and you will see all the footprints that you have. And on the left side, you have the libraries. In the case of the FabLab library, it's called Fab. And in this window here, you can see how the different footprints look, okay? Here it helps as well to, well, first to get familiar with the footprints, but also to see if the one that you think that you're importing is the one that you actually want. So here, I'm gonna look for the component, and I don't know which one it is. So here you see that there are different, let's say, options. And we'll see this tomorrow for the academy, but these things here, SOIC, SOT, etc., SSOP is what we call the packaging of the chip. And this is, you see that they change the shape. There are different packagings, and by that, there are different formats. Same microcontroller can have a lot of different packagings, and this code here is what determines the packaging, let's say. So I wanted this one is the one that I had before. So if I double click it, it's gonna put it in this field. If you want, you can also put a data sheet. That is a good practice if you want for like more advanced electronics design. But with this, we're good. Once you have this footprint here, you press OK, and that's it. Again, how did I get in that one? Either you click, you just put your mouse over and you press E, and then that window comes up, or right click, properties, edit properties. Yeah, you good? So now that I have the footprint again, I go to PCB, I reload it, there's no errors, very good. Okay? Close. Is everyone here or no? Or are you lost? Mark over there, what happens? Yeah, should I go on or not? Maybe Joseph can make a round in this table afterwards if you can. Okay, so now I'm here. So you see that this is basically like how KiCad put the components, but there's no actual physical board here. Here we have to start arranging them, and here becomes the fun, let's say. This is where the first days you're gonna have a lot of struggle routing. You have to put the components and make the wiring connections so that they match, let's say, and that you are able to fabricate them. And this is where the craft and the skill comes into place, okay? Experience as well with time, you will get less frustrated. At the beginning, I'm sorry, you have to be a little patient. So we have these components here. The first thing that I do is I spread them out a little bit, and I make a little bit of organization like in my head so that I'm able to later on visualize things properly. Here and now, right now, I have a lot of white hairs here that I don't know what they do. I don't know, I don't see clearly the connection, so it's better to just spread things out a little bit. And I don't know about you, but I like microcontroller to be like vertical. I'm gonna put this button maybe over here. You see that the same applies as before. If you put your mouse over it, you press M, you move. If you press R, you rotate. It's the same as before. Here you could copy, but it doesn't make sense to copy because you should copy in the schematic, not in the layout editor. And here we go. So we're gonna just move things around. You see that little by little, the circuit becomes a little simpler by just placing the components right. And honestly, there's no right or wrong answer here. It's just a matter of how do you want your circuit to be, okay? So maybe this could go, I don't know, here seems okay. And here looks good to me. Okay, here, one thing, I don't know if you've noticed, but I have a problem here. This resistor is connected to this pin, but it's not connected anywhere else. And this is because I think at the end of the class, I changed the label. So I'm just gonna come back and fix it. Is this, by the way, if you can look at the screen 1 second, all of you, if you have a component selected and you click on a schematic, you have that component selected in the schematic. That way you are able to identify which one it is. My problem is that I lost this label. VCC, okay. VCC. I reload, update, close. Okay, good.
When we move the components, the connections jump. Is that normal?
Like they jump? How do you mean? Like they... Yeah. Okay, so this white hair here, it's basically to the shortest path. So if I move it, and if it goes, you see that it now, the ground goes from one to another. At the end, all of these are connected, and it's just indicating that at least to that one, you have to connect it. And it doesn't matter if it's the closest or the farthest one, it's just, you have to connect this, okay? And you know that this ground, all grounds in the circuit have to be connected, all of them, and they all have to share, the circuit always has to share the same ground. I'm never gonna be tired of saying this. So if I move the component, there's maybe a closer ground somewhere else, and that changes, but it's okay. So I don't know what you think, but for me, this probably is a good place to start. Now that I have this, I'm going to make the, let's say, what I see here a little bit simpler. And I'm just gonna hide this layer here. Silk is basically what we print on the PCBs on top of them, which indicates the values and the logos and these things. So I'm just gonna hide it, and that way I have a clearer view. You see that all the components have red footprints. That means they are in the top layer. It's in the front copper that I was telling or was saying earlier. Is, let's say, the view that I see the nearest when I look at the PCB. If they were in green, it would mean that they are in the back, so on the other side of the PCB. For now, you want them to be, all of them red. And you will be saying, okay, but there's something green in there. Sorry, green. There's something yellow here. What does yellow mean? Yellow means that they have a hole in the middle so that you can connect something onto it. In this case, we're gonna put here a microcontroller like, we're gonna put a microcontroller like, this one. It's not the same, but similar. So we have to go through the PCB and solder. So that's why we have this hole in here. And that's why this is yellow. Okay? Yellow means it's a pad with a hole. Okay? And the rest of them are red. Are you good till here? It's called pad, P-A-D, and it has a hole. Yeah? Okay, good. Yeah. Actually, what I just said is not fully accurate, but this means that this yellow pad, we can touch it, let's say, from the top part of the PCB. This red one is hidden. If we were making a professional PCB, it will be hidden, and we will be able to touch it only for putting the component, but that's it. And this one is, let's say, intentionally exposed, and it's a little bit more rigid as well, so that you can put things through, let's say, like a hole or things like this. So now, before starting putting things or wires here and there, we have to check something that is called design rules. What are the design rules? So as you can imagine, from different manufacturing processes, we will have different ways or different limitations, let's say. As if you imagine how we manufactured these past weeks, we used an end mill that is basically removing copper from the PCB. And what we want to do is have at least the components separated enough from one to another so that the end mill can go through, right? Otherwise, we cannot make the traces, or we cannot actually make our circuit. Is that clear? So we actually, what I'm trying to say here is that the manufacturing process is putting a limitation on how close things can be to one another, because the end mill is not able to go through otherwise. Imagine that I put this here, super close, and that I'm asking the end mill here on the machine that it has to go sorry, let's cut drawings. So I'm saying that the end mill that has this diameter has to go here. It can't go into that, right? The same way that in this case, it can go here. It can go here, but it cannot go here. As you can imagine, this is getting a little complex. So we have a little help from the software with what we call the design rules. And design rules, you can find them in File, Board Setup, Design Rules. Yeah? Basically here it says, what is the minimum track width that we can use? A track is, let's say, the pad, or so the path of copper that we leave, like the wire. Bias we are not going to have at the beginning, but we care about the track, and that's why Top Academy people did this test 2 weeks ago to be able to determine what is the minimum width that we can make with these machines. Do you remember the value? No? I'm gonna keep it like 0.2 for now, that's good. And here, if you go to net classes, we'll explain what net classes are in a future class. For now, it's too much information. But in the default net class, so everywhere, we need to be careful with these values here. Clearance is the separation between footprints, and here it's important that the tool is able to go through. And you know that we have a tool that is 1/64 of an inch times 25.4 to convert it to millimeters. So that means that we have at least 0.4 millimeters of separation so that the tool can go through. If we put them closer, the tool is not able to go there, and the pads are going to be connected. So why don't we just change this and put the clearance 0.4? That way, the software is going to tell us you are putting things too close. I cannot put the tool in here. For track width, I would recommend to go somewhere around 0.3 at the beginning. we'll see that for this small toy example, 0.3 is probably even too large, but is a good default value. If sometimes you need something a little bit that is thinner and that has to go underneath a chip or something, you can make this a little bit smaller. And especially if you're connecting something very large like a motor or things like that, I recommend that this goes up, because otherwise your circuit is going to heat up. Okay, this value in like normal, let's say, power line could be 0.8, even 1 millimeter. And here it's not like I'm making this up, but you, for instance, could go to, sorry, here, not here, to tools, calculator tools, and track width. More or less, imagine that you have a motor of 2 amps, but you don't want a temperature rise of 10 degrees, that your wire is going to be, I don't know, 10 millimeters long. So more or less, it tells you that 0.8 is a good value. It calculates for you the track width. Okay, this is for external layers. Let's say for layers that are almost in contact with air, that can evaporate or that can evacuate a lot of heat. If they are inside the PCB, you know that there are different layers and that can be hidden inside the PCB. Since they cannot evacuate so much heat, the trace width has to be larger. And also you see that this is the thickness. 0.03 is the normal thickness that we use in the layers here. And for an input current of 2 amps and for 10 degrees of temperature increase, 0.8 is a good value. If you have a larger motor and it consumes 10 amps, well, you have to put 7 millimeters. Either that, or you compromise a little bit conductor length. Maybe you want to put a very short conductor length, like 5 millimeters. Or you accept a little bit of temperature raise, and you say, okay, maybe for this application, I'm okay if it's 15 degrees, and I can go down a little bit. Here, of course, this is a little bit advanced, but keep this in mind, okay? And where these things come from. So coming back to this file, board setup, net classes, we said that the clearance 0.4 is okay. The track width 0.3 is okay. And for the other ones, for now, you don't have to worry, because they are for the cases in which you have 2 layers. And you have the via size and the drills, which are the sizes of the connections between the top layer and the bottom layer. Okay? Once you have this, 0.4, 0.3, press OK. And you see that this has changed now. This separation from the footprint to this outer line is a little bit wider. It's because we updated the design rule. Okay, before this was a little bit thinner, let's say. Sorry, I really cannot hear absolutely.
So you already have like holes in the board because you have the microcontroller. So I was wondering, because you said that the via is not that relevant, but because you have those through holes, is it already like a 2-layer board?
Okay, so conceptually, in principle, yes. But the idea for this one probably is not the best example. But how this would look on the actual PCB is that we have our board. Here we have this little pad, and here we have the hole. Okay? Here is where we have the microcontroller. So the microcontroller is above here, and the leg of the microcontroller comes here and goes through like that. in principle, we would be expecting to go here, here, and this is the hole. The same hole goes all through. And here is where we put, ideally, is where we would put the soldering, right? This we will put solder paste, and that's it. But since it's only one side, what we do is we put the solder here. And this one, we don't put it. And it stays like that. Yeah? So we have the hole, and we put the solder on top. That's for single layers that have this side. How could you do this otherwise? Think that your PCB could be as a two-sided PCB, but with only one layer on one side, which means that the copper in this case is, and maybe this is a little bit confusing, but the copper in this case is on top. So this is the side with the copper. And I put, for instance, a resistor here and another resistor here, etc., with the footprints like this one. So this is that. And then the microcontroller, I put it on the other side, and I put it here. The hole, in this case, can go here. And the pad goes here. And the leg of the microcontroller, in this case, comes here. And I have all the solder on the same side, and I close it in here. So it means that some components are on the top side and some components are on the bottom side. You see this in many prototypes, it's very common. But one thing that you have to do here is remember that this microcontroller here is on the other side of the PCB. So you have to flip it. How do you flip that? You press on the microcontroller and you press F. And now it's mirrored, let's say, and it's on the other side of the PCB. This only works for single-sided PCBs that have holes through them. By default, let's say we would try to just keep all the components on the same side and not get into this mess because it's a little bit more confusing. But just so you know, okay? Yeah. So as I would do it now is I would put the component on top and solder from the top, even if it's not the best. How you would do it professionally is that you put it like this, and then you have all the components, SMD components, on one side, and the microcontroller comes from the bottom and goes through the different paths. Yeah. By the way, I said one thing there is SMD. SMD stands for Surface Mount Device, I think, which is, let's say, something that you put on top. Electronics, and that you solder on top of the board, like this. So all these components you see that are mounted on the surface, and that we put the solder here, all of these, they mount on the surface, so they are called SMD. These ones that go through a hole, how they're called through hole. Super simple. Okay? These ones too. So the microcontroller, all these capacitors, resistors, LED, etc., are SMD. These ones here are through hole. Yeah? So now, let's keep going. I'm going to start, now that I have designed my design rules, I'm going to start doing some wiring. I'm quite happy with how this looks. I'm just going to hide that. And to start placing some wires, in here they are called tracks, We call them indistinctly wires, tracks, or traces. And you select this component, so this button here on the right side, green one, route tracks, okay? You press in here, and again, our friend, the crosshair comes up, and as soon as you snap onto, let's say, one pad or one component, one footprint, you see that the connections show up, let's say, or are highlighted, and the other ones are shadowed, and you can see, like, visually where you want to go. So very simply, I'm just gonna wire this one here. They normally keep these 45-degree angles. If you want to avoid that, you have to do more clicks, let's say, only because it just saves copper and it saves distance. So I put this, I join this one, go here. Maybe I want it like that. I want it like this. And then this one, I'm gonna go, this one, I'm gonna go here. Okay? So all of a sudden I have all the grounds connected already. And that's good, okay? These wires at the beginning, I recommend that you try and iterate. You're not gonna get it the right way on the first try. So this comes with time, be patient and gain experience. It will be a little difficult at the beginning, but you will get better at it, okay? What happens if you messed up? You can put the mouse over the track and then delete with the backspace. Or again, right click, delete. Okay? Good? So now the purpose is that we do some wiring. So I'm just gonna do it as I would do it. Gonna start doing some connections. Here, for instance, I already have a little dilemma, but I can go just here, boom, connect this one, connect this one, and here. So our PCB is routed, okay? At the beginning, of course, again, I did it super fast. I've done a lot of PCBs already, so this process is kind of like intuitive, but try and error, okay? You have some visual ways of getting some help. Some things here, there's one, sometimes some of you might know that there's something called auto router that basically tries to solve this problem for you. I'm not gonna show that, first because I never used it, and second because I don't think it's a good practice, because I think it's very good to develop this intuition. Do you know how to do this thing by yourself? Even if at the beginning they're a little bit painful, okay? Things to consider here. Traces, when they go, let's imagine this case. I can route from here the closest possible to here. And in principle, if I set the design rules, okay, it should be fine, but it might not be fine. Let's say, this is not what I want because this is prone to errors, let's say. I don't want to put myself into an uncomfortable situation in the future when I mill this and something happened and all of a sudden I have a short and I don't see it. So I would suggest that you leave sufficient space between traces and footprints or pads so that you don't run into problems in the future. So don't be stingy, let's say, with the space at the beginning, especially. Try to make your boards a little like with that breathe, let's say, okay? Other things that you could consider here, sometimes you'll see that in this case, you can play a little bit with the program, meaning that I know that this is a button, and I know that the two sides of the button are connected. Maybe in some situation, if I wanted to have a trace like this, going underneath, it's not convenient for me to join them here because I know that the button physically is connected inside. The button itself or the switch has this connection made, and I know that already. So maybe sometimes I don't put this one and I just accept that there's gonna be an error and that the program is gonna tell me, but okay, it's fine. Other comment that I will say is that I rather, and this is just my personal opinion, I rather do connections on the pads than on the wires. So I rather do something like this. So have this and all of them routed to the same spot rather than do this. Why? Because this connection is much weaker than this one here. There's more material here than there's here. So I rather just do the connection on the pad than on the wire. Sometimes you cannot avoid it, but if you can choose, you can just connect directly to the pad itself. Okay? Are you more or less still there or not? Questions? Yeah, whomever. Go.
Okay, it's a question about the track list. So, where do we make the track list a little bigger so that
you could, yeah. So if you wanted for the first boards, the track width could be 0.4 or even 0.5. And well, you see that they don't update. I'll show you how they update now, but it's okay. If you want at the beginning, you, for instance, imagine that all of a sudden you make this and for whatever reason, this trace breaks. If it's a little wider, it's easier for you to solder on top, and that's a good idea. Yeah.
And I guess when you start positioning and rotating components and so forth, it just comes with practice. Right now, my board looks like it's
yeah. So if, for instance, I move this one, the traces don't go with me. That's what you mean? Yeah. So what happens in this situation? Imagine that I move this and that I put it in here. Okay, it's still okay. It's connected, but I have this little part in here. Or actually, yeah, let's leave it like that. So the first part is that we're gonna change edit track properties. Yeah. We updated the, let's say, the design rules, and that we want to update the board. They still are 0.3, I want to make them 0.5. I go to edit, track and via properties, and then I select what I want to change, tracks. So I only want to change the tracks. I don't want to filter them, I just want to take all of them. And I want to set them to the values that are defined by the track. Or I could just change it, no, I couldn't change it manually, sorry. Or I could just set it to this specified value or to the net class values, which is what we decided here. So I pick this, I press OK, boom, all of them are updated. Okay, you don't have to update them manually by hand. You can edit tracks and via properties and just follow through. What do you want? If you want to filter, and what do you want to do? Simple. Imagine that I want to edit a single track. For instance, this one here, I want it to be wider. One trick is, you see that I'm only selecting one part of the track, let's say, but I want to select the whole track. So when I select one part, I press U, letter U, and then I select everything. and then I press letter E for edit, and I edit it. And here I can pick 0.5, the net class width that I defined before, or I could just say this one, I want it to be 0.8, and all of it, and it changes. Okay, this one is a little wider just because I want to. The last thing is that what happens with this guy here, this part that is unclean, and that you'll see that this can happen many times, and that you don't see them sometimes because they are under other traces or on other footprints. So you go to edit, and you say clean up tracks and vias. Click there, and be careful with what you do here. Delete dangling tracks is what we want. Merge overlapping segments, delete redundant vias, delete track segments connecting different nets. Depending on what happened, if you don't understand, don't leave everything on, just click what you don't want. And I think it's obvious here, delete dangling tracks. Okay, and it deleted for us. Sometimes you don't see this, and you have to be careful for that. So I can now connect it back. What happens if I don't see this? You might be wondering, well, I have a lot of pressure. I have to pay attention to the design all the time because maybe I forget about something. Maybe I have something that is connected in the bottom and I don't see it. Okay, we have this little bug here that is gonna be your friend many times, which is perform design rules check. You click in there, and it basically has two tabs. First one, well, you just click run DRC, and you see that it's telling us that we have some problems, and that here on the right side, it says unconnected items. Basically, if I select it, it shows me. It's here in the middle, I have something unconnected. And it said path 1 of C1 on FCU and others. It means that VCC is not connected to VCC. And in the schematic, I said I have to connect it. So I can just close this. I fix my problem, go back, run again. Now the unconnected item is gone, and still it says track too close to board edge. This is, let's say, not very clear here, but we don't know where the board edge is because we haven't defined it yet. So it's complaining about it. And there's basically no board in here. We don't know where it is. And don't worry about this one now. These problems are not actually there. And they're all the same, okay? Basically, it's talking about the tracks that are, let's say, outside of the footprints. That is what it considers by default the board edge that we don't have. Are you okay till here, more or less? Okay, so now, let's imagine that we finished our design, we checked our design rules, we cleaned up tracks and vias, we have everything ready, and we say, okay, I'm ready to, let's say, put some shape onto my board, and I'm gonna start, let's say, making what we call the outline of the board, okay? So we've been working until now into the front copper, so FCU, the red one. Now we're gonna go to edge cuts. It's a yellow one here, it says edge.cut on the right side. And here, instead of using this track button here, I'm gonna use these elements here that allow me to draw some basic shapes, let's say. Here is not the best interface. We have to admit it's not the best drawing interface ever. So don't try to overcomplicate things at the beginning. I'm gonna give you some tips, my experience that I gained through iterating and failing. And imagine that I want to make this in a square form. I can select this polyline here, and I can go here and just make the outline. You see that as soon as I get to the endpoint, it has a, let's say, a circle around it, and that's it. That's done. Okay, this is ugly as hell, I don't like it, and I want some round shapes. So I could do that and then start drawing some arcs, but I learned that with time, this is not the best way to do it. So what I do at the beginning is I draw the corners and then I draw the straight lines. So I press add graphic arc, and I say that I want to draw the arc here from, let's say, from this point till here. Does that? You can edit the arc here. So more or less it says 90 degrees and it's already like a nice straight arc. And what I do, and this is my workflow, if you have another one, tell me, but is that I take this one and I copy it on the center, and then I paste it, but rotate it on the other ones. That way I know that I have the same one. I rotate it, and I rotate it, and I put it here. Now, how do I know that it's on the exact point? Well, I have to come here and take these coordinates and fix it. Imagine they're all perfectly aligned. Now I go here and just join the dots. Take this one here and go to this one. And again, this is not the best interface, but it's something. I join to this one, and then I go here. Join to the next one, and the last one here, okay? And okay, it's not the nicest board, but at least it has some curves, let's say, and it's a little bit less ugly. Now, one thing, if you want to see that the outline looks good or not, you can press Alt-3, and you see the 3D view directly, and you see that the outline is closed. It means that the actual profile that you did outside is really closed, is not opening in any point, and the program is able to determine the PCB. And this is actually how the PCB is gonna look. As you see here, you have some of the buttons. You see that this is actually gonna be printed on the PCB if you send it to manufacturer. You won't see this on the milling machines unless you put them explicitly on the copper layer. But here you can start arranging things, and you can move the silk screen if you were going to manufacture this professionally, etc. Imagine that I like it. I don't know how to put the components in here. Giuseppe maybe can tell you that later. But basically, now here I have my PCB, I have the outline, and if I run the DRC again, all these problems that I had earlier are now gone, because now the board is clearly defined and I know where the outline is. What happens if I delete this one and I go back to C? It gives me, and it tells me unable to find the segment, whatever cannot determine the board outline. One thing here is that, I just want to highlight this for a second, is that all these programs are very verbose in how they explain things. So please read the messages. Don't just go here and okay, I don't know what happens and I close. No, just read, because it's explained in there, okay? It will save some frustrations for you and for me in the future. So now if I close the outline again, go here and here. Can save it, all three. My outline is back there, all good. Okay, we're almost done. Are you still there? More or less? I know that this is, but you got used to it while you try yourselves, okay? Do you have any questions? No?
is why.
The mic is coming.
I'm not sure why, but half of my wire connected to the microcontroller, and the other half, I don't know why they are not. They are here, but they still have that line in the wire.
Okay, so I think you said that it can help you, but probably you moved a little bit the microcontroller at some point, and it went out of place, and the tracks don't go with it.
And that would be like the drag is too big, the drag is too big, so it cannot be inside the two, like the two pins. So we need to reduce the size of the drag.
Okay. Yeah, of course. Okay, just one tip. Imagine that we were actually manufacturing this, and I want my board to look nice. I can move these things here. This is what is going to be printed. So I can align them. There are some ways to, let's say, make it look a little nicer. I can maybe delete some or even hide them. This, for instance, I don't need to see that it's an LED. I already know that. Maybe this one here, yes, I want to keep it. And visible. I want to know what, I like to put the, let's say, the ID of the component and the value on the board so that when you solder it, you know what it is. Okay. And that's it. Now when I look here, well, the board is not there yet. There's some problem here, but it looks much nicer already. You don't have to do this because you're not gonna send them to manufacture. But if you want to take a nice screen capture of the process and put it in the documentation, this looks much better. And now we're gonna export, or we're gonna, let's say, cross the layer between design and preparation. If you remember here at the beginning of the class, we were talking about the different stages. And we basically finished the design part. I'm talking about this workflow here. So basically we're done on KiCad, but we have to export the files, okay? Now, I think this is time, well, we're gonna see two methods. I'm gonna show one, and you can show the other one. I'm gonna show the way that I do it, and then Giuseppe is gonna show you the way that we normally do it, let's say at the beginning. But if you want to do this many times, I'm gonna show you a hacky way to prepare the SVG and make the PNG, okay? So for doing this, basically our objective is to generate an image like this. And we have to generate that from KiCad. We cannot do all the process from KiCad directly. We will first export an SVG. We will treat that SVG and convert it into a PNG. And then that PNG, we will put it into fab modules or mods and send the instructions to the machine. So the first part of converting, let's say, the file from KiCad into an SVG, I'm gonna show you my way and how to convert it from SVG to PNG, let's say, the same. And then Giuseppe is gonna show you the way with an extra component that, or an extra program, okay? My way is here. If you go to the very end into the export part, you'll see that there's a link there that says KiCad exports. That brings you to a repository for with instructions on how to set this up. Okay. The idea of this is that you're gonna create a button into KiCad that is gonna make this process for you, and that is gonna make your life a little easier in the future. So here you have instructions. Basically, what we're gonna create is this FabLab exports button here that by default is not there. If you open KiCad and you go to tools, external plugins, you don't have this FabLab export in there, in principle. No? So we're gonna put it there. For this, you have to go to this repo and you have to follow these steps in the repository. Okay. I think that it's a little late, so I'm just going to show you what the final output is. Once you have so that Joseph has some time also to show you the export. I'm going to show you the final output and the process, but if you follow the instructions here, you can let's say, have it done. We made this, so if you see that there's any way to improve it, we can change this repo. It's in FabLab, okay? It's FabLab Barcelona projects. Okay, so imagine that we have it all set up. Tools, external plugins, FabLab exports, boom. There was a blink in there where it was super fast and you didn't see it. But now, if you go to your folder, there's one folder called exports, and in there you have already SVGs. Okay, this is the board already. But this is a vector file that has the traces and everything. And you have different ones for the top part. You already know this one from electronics production, the copper and the edge cuts. It also generates one for the drills, because in this case we have to make the through-hole components. And in this case as well, we have the pack of the board as well with these traces here, which we just basically can ignore. In this case, we export them, but they are not necessary. And now this is where my terminal comes back. And if you install Inkscape, I recommend that you install Inkscape on your machine instead of Illustrator. Why? Because of many things, apart from, let's say, personal belief, but one of them is this one. And is that if you go here into exports, and I'm just gonna take this command here, bam, bam, bam. Inkscape, this one? No, Inkscape. No, what was this? Inkscape, exactly. You just type that, ink, X, and everything. Inkscape does its thing. You see the Inkscape is running there, makes here and there. And all of a sudden, we have some PNGs in here, nice and clean, ready to be milled. Less than 1 minute if you get used to it, okay? I'm not asking that you do it the first way, this way, but you have the instructions there. And I think that you will thank us for this workflow in June, once you have to do this 10 times and you suffer with Illustrator and Inkscape and everything, okay? So now you can take these two Fab modules and start milling. Yes. Exactly. Well, actually, this, you have to put it in Fab modules or mods. And I traditionally use Fab modules. Let's just check that it works. So input, PNG. Sorry, I still use I learned with this one, so I still use this one, but Giuseppe is a master in mods. I take this one, output format, roll and mill, process 164. I want to invert the image. Remember that we're going to cut on the black side. So if we cut the black side, then we don't have electronics. We just have the negative. So invert image, SRM20. Let's just see that it calculates properly. There we go. That's our electronics. And here you just have to review that where you want there to be a tool path, that there's actually tool path. I mean, here, for instance, we are a little close, but still the tool passes twice. Here we even pass 4 times. Here we pass many times, so we are good. We're ready to change the zeros here, 0, 0, 0, etc. Calculate, save it, put it in the machine, made. Okay? Good? So I think now it's time. Giuseppe can show you the process with Inkscape and everything. It's going to be, his way is very clear. So at the beginning, it's easier to do it as he does it, because you'll get the concept that you have to make an SVG, you have to fix the image, you have to export it as a PNG, and you have to post-process it. Once you are used to it, you can go into this other setup that is quick as that, but at least you know the concepts behind it. Okay? The floor is yours, man.
Sí. ¿Quieres que lo tuyo? Sí, no sé cómo de maravilloso va. KiCad, si quieres mover eso para arriba. Okay, so this is like the easy and slow way to export the boards, okay? For this, the first thing we need to do is whenever you finish routing your PCB and everything, you have to export it and export it as an SVG. So this is the same that the plugin is doing, but let's do it manually here. And what I will do is I will export the front copper layer, because I just want the front. And if you want, we can export also the edges. Here with the edges, I also prefer to always make the outer cut in Inkscape, because it's like more user-friendly, let's say, and it's easier to, if you want to make different shapes here, it's easier. Let's do it like that, and then I show you inside Inkscape. So just select the front copper, the edge cuts. Important here, the default pen here. This is the resolution it will have a little bit, so it's important to have it at 0.01 in black and white, because we want the image in black and white. And board area only. This is important, so it will export only the board and not the full screen. And here all layers in a single file. So like this, we have the same file for the outcut and the full PCB. So let's do export. Well, here we can define where to save it, but it's fine. We're going to save it on the folder of our project. And let's click export. You see, exported. And now if we go to, sorry, I don't know Mac how it works, but here we go back to our class. You should see that here we have an SVG. That is the board. Well, here in that case, we have the board with some border, but it's okay. We can clean this up afterwards. So here we have 2 options. The options that we push for is Inkscape, because open source, and it gives you and really in this case, it works better. Or if not, like Illustrator or any other software, vector software, okay? The problem with Illustrator, we have a lot of problems, because with Illustrator, when you import it, it doesn't import well the size of the tracks and everything, so it's messy. So I encourage you to use Inkscape instead, okay? So let's go to Inkscape here. We have Inkscape here, and we can open file, open. Plus, here we have the SVG, perfect. Let's open this SVG. And here, perfect. Let's do this. Wait. I don't know what I'm doing. Okay, this. Okay, sorry that I'm not used to Macs and I don't know how to zoom in and out. Okay, so here you see, this is our PCB. So what we want to do here is like create the final images for exporting them. So I always start with creating some layers. So like this, I can show and hide different layers to export the different images. Because here we need an image for the traces, an image for the holes, and an image for the outline. No? So let's create. I always like to use a background layer first, then a layer for the traces, then a layer for the holes, and also a layer for the outline. Yes? The layers here, you can go onto layer and layers, and it will open the menu on the left side, on the right side. Sorry that I had it open directly. Okay. So we have different layers here. Let's do one thing. For example, let's select first. If you click on some of the parts, it will select like the tracer itself. So this you can right click and you have move to layer. And let's move it to traces. So now I have. One second. Let's do. Yes, it's fine. Sorry. Let's do it again. This, move to layer, move it to traces, move. Now you see that like the small holes disappear. This because we move all the traces to a top layer, so it's just underneath that layer. So if you want, we can hide the traces here and just like select whatever we have in the middle, and you will see that we select all the holes. So all these holes, we can do the same. Right click, move to layer and the holes. So now we have these holes onto that layer. So now if I show the traces, you see, as I have traces and then holes is the top layer, you will see again the holes. Okay. Then for the outline, the same. We can click on the outline and move it to the outline. Sorry, like this. Right click, move to layer, outline. Okay. If you want to change layers, also you can use like the menu here on the bottom part, and you can select which layer you want to put the selection. Okay. So. Let's do one thing. We will start with the traces. So let's hide everything except the traces. Yes. If you want, you can export it like this and invert it onto mods. But I always like to invert it here, so less problems for mods. So what I do is always I create this background layer here, and inside this background, I just create a square, like bigger than the traces and everything. It's just a black square here. You see that this is on background. If you want to change color, you can just click on the colors here. But if not, now we're gonna open the menu for colors also. So we have the background here. If you want, we can change the opacity a little bit so we can see underneath and the traces and everything. So let's go back to normal mode here and let's select the traces. So those traces, Now what we want to do is change the color of them. For this, we can do like object, fill and stroke here. And you have like the color menu, or you can directly click on the color. So I will click for the white. You see that it only changed like the footprint itself, because the other parts are traces, so are vectors directly. So if you want to change that color, you have to change the stroke paint here. So we can change it to white, or we can hold Shift and click the color down on the color menu here on the bottom, and it will change also the lines, okay? Perfect, we have the first layer done, no? In fact, if we select, we go to the layers here, and in the background, we put back up the opacity. We see that this is the image that we want to mill for the traces. Let's finish all with the holes and the outline first, and then we export all of them together. Because if not, this is important. When we are exporting, we need to export them at the same size, because if they don't have the same size, when you calculate the different strategies, they will be moved. So it will not be aligned when you cut the different things. No, so always export with the same size. So for that reason, for this reason, I want to have the outline also. So we have the traces, perfect. Now let's go for the holes. And here, in here, okay, we need to select all those small holes here. How to do that? Like I just drag and drop a selection, like a selection square, and I select all the holes here. And those holes, you want to have them on black because you want to mill them. So we want them to be black. So we change the color. That's it. Okay, and then let me do, so remember, holes in black, the traces in white. Let me do like this outline here. Also, we want the outline. Second. This is what happens when you grab another computer and you don't know how to use it. So you see this. You see the outline here is a super thin line. This, if we export it like this, the end mill will not have a space to pass, so it will not cut anything. Because here the end mill it's a little bit thicker, so we need to make it. We need to make this line thicker. So for that, we can go here onto the stroke style, and let's change this. So the end mill that we have, the 1 divided 32 inches, it's in millimeters. Let's calculate it. 0.8. So it's 0.8. So we want to go bigger than 0.8 in millimeters here. No? So let's put 1 millimeter, for example. See, like super thick, but better like this. So the end mill will have a space to pass here. So now if we wanted to, this also for the outline, I always like to create it myself here in Inkscape. Normally I don't create it on KiCad, and I create it here because here like it's easier to imagine. If you want to create just a square, like it's easier to create it like, without fill, black line, and here like you want to make it round, you can round the corners, and let's say it's easier to create shapes here than in KiCad. Yeah. Also, if you want to go crazy and create some strange shape, in KiCad it will be a nightmare. Here it will be easier, yeah, because you can cut boards with any shape you want. Like if you want to make them the shape of a dog, you can do it. Like,
actually, it would be nice if someone makes like a weird shape. Mostrar todos los places.
yes.
Por background. Y pon el outline un momento en blanco.
Vale. Dale, es que voy con el zoom al revés, tío. ¿Sabes?
O en otro color, solo un momento.
The outline here. Let's put it in white, for example.
Okay, so
Está el modo en principio.
So just one thing, if you imagine that you have made the trace is very close to the edge, and you didn't predict that, it's good that you edit this in Inkscape, but when you change the width, at least you give it still sufficient space. Because maybe it's too close to the edge, and you will cut the trace. Okay? If you go back to Inkscape, to KiCad.
Yes.
Sí. Vale. Selecciona el este. Sí.
Tienes que
Este, right. Edit. So if you want as well, you can change the width here directly. Instead of 0.05, you can change it and just make them 1 millimeter. And that way you at least see if you want to make the drawing in KiCad, you can see it from there. Otherwise, the way that you do it in Inkscape, but you don't see the outline, it can be online.
Yeah, now you see when you increase the width here, like it's increased from both sides. So if it's super close, it will be touching and you will cut the traces. Let's go back to Inkscape here. Okay, so now we have everything we want to export. So it's just a matter of hiding and showing different layers, yes? Let me change the color here of the background again. Of the outline, sorry. So first of all, I will go with the outline because this will be the size I want to export, just the size of the outline. So the first thing we want to do is open the export PNG image. This is a menu that will open here on the left side, on the right side also. And you see here, this is the export menu. So here we can say, no, export the whole page, export just the drawing, export the selection, or export like custom export, no? What I always do is always start with selection. So I can select my outline. And once I have this, the outline selected, I just change to custom. So if I select whatever, like anything else, it will like maintain the size of the selection here. So see, check here is. Let me just select the outline. You see with selection, it just like gets the coordinates and the size of our selection. So when we go to custom, it will save all these sizes and coordinates. Yes. So now I can click wherever I can and select that. This will keep the same ratio. Okay. Important here, the pixels, they have to be like always exported in DPI 1000 because we need to have a super good resolution so mods can read it. Here we can select where we want to export it. I will put it on the same folder you have it, okay? Not in the exports, but you want it in the export. Let's create here, maybe we can even create a new folder. And let's say exports, well, let's say manual exports. Okay, so let's do it in here and save here. Oh, sorry, export as ¿dónde lo he creado esto? Okay. Manual exports, okay. Here the name, this can be outline. Perfect, so we have the name and we can export. When you click export, no, pone solo porque solo el PNG, you don't need to put the PNG extension because it always saves it as PNG. So it's just the name, okay? So when you export, it will export just the outline, perfect. Now, let's go up here on the layers and we want to hide the outline and select the holes. So we just want to export these holes. Yes, Denise? How do you know the size is correct? Here, when I save the export here, I select this, I did selection. Let me show the outline before. Okay. So here, remember, like you have different areas you can export, no? So what I did is I selected the outline, perfect, and I did selection here. So imagine if I select here now, when I select, it changed all the sizes, yes? You see that it changed the size here, and also the coordinates. So I select now the outline, that this is like the bigger cut you have, no? So you always start with this one. So when you do selection, so it changes to the size of this selection, and then you change to the custom tab. And this custom tab will automatically save the selection you had before, no? If you come from selection, then it saves the last you had there. So now you see, now we have this size. So if I select anything else, it will keep that size and these coordinates. So it will have the same size. Okay? So let's export now the holes. For the holes, we just want the holes. So let's go. Let's also hide the outline. Let's go back on the export, and now we're gonna export it as holes, for example, no? Okay, export. I recommend you not to use like the names outline, holes, and traces always, because you will have like millions of boards with those names. So I recommend you always to put some name here, like class example, holes, no? So like this, like you have for each board, like you have different names, because if not, it will be messy. Okay, in that case, I'm gonna do it like this because it's shorter. Okay, we have the holes. Now we want the traces. So let's put the traces. We cannot see them because they are white. So let's also light up the background. Let's export the image again. You see the size of it is the same because we're in custom tab. And we can export them as, instead of holes, we are going to call it traces. And export.
Change the size, the thickness of the traces, right?
No. This is important because like the thickness of the traces, you define them on KiCad. No? If you change them here, you pack all your design. So here, only if you need to change any thickness, just the outline one. Okay. So normally we have everything here. Now, if we go to manual exports, you see we have the holes, we have the outline, and we have the traces. This is good, but I want to show you one thing, like one like a small trick, let's say. So if you go to mods, well, let's use. Let me go to mods. Sorry, Oscar. Mods project. That is the one that we already showed. It's programs, open program, SRM, PCB. Here we want to like import a PNG image, yes. So select this PNG. Okay. Exports. This is just for the outline, what I want to show. So you see here, it's just one line. And let's go in outside 132. Okay, this we should change the speed and the coordinates and everything, but let's calculate and see what's happened here. Okay, it's finished. You see that we have two lines here because we have two lines because this line, like we have white in one side and white in the other side. So we have white on the outside too. Then it will try to cut the black for one side of the white and from the other one. No? So it will cut it twice. We don't want that because it will take much time. It will take more time, and also it will create a super thin, like a thin layer of board that it will pop out and can break our edit. No? So for that, what we do, it's here in Inkscape. When exporting the outline, now we have the outline here. What I always do is, okay, I select this outline and I fill it with white color. So it will be white in the inside. And I also show the background. So now have it here. Sorry, this has to be white color. Problems here. Eh? We have here the, sorry, the color. So fill, you see, we want to have it like important here. Okay, this is also a
La outline es un stroke.
claro, claro. Let me go back here, wait a second. Sorry for that. Now I destroyed it. Wait, sorry. Command Z, Command Z. Not control, but command. So this is the problem with making it with KiCad directly, that this, let's say, it's not a, this is not a rectangle or a shape inside. So for that, this is more tricky now. Well, the easiest way is to create the, well, let's grab the background itself. By selecting the outline. Right. Again, select the outline, background. I don't know what to do. Try to keep.
Por ejemplo, quieres un outline relleno, digamos.
Sí.
Quieres un outline blanco, relleno de blanco.
Claro.
Y no puedes hacer un fill de esa forma.
Esto, maybe we can select this path and make it combine. So now this should be a path, and we can make it black. Really? Yes.
Okay. A nivel de principios yo creo que están... ¿Puedes hacer como el bucket este dentro?
So we can use the bucket directly. Command Z, Command Z. So let's select the bucket, select the color, and fill it with white. Show the, okay. So when we want to import, sorry, let me go back and do it again so you see how we did it. It's just okay. So here we have the outline, and we want to fill it. We want to fill this outline, so we are going to select the filling bucket, select the white color, and fill it inside in white. Like we cannot see anything now, but when we show the background, then it's like the background with the white image inside. So this is what we want to export. So let's go back onto the export menu. We find it here for PNG, and let's export this one as outline. Export it. It will say to replace. Let's say yes here. Exporting. Okay. Now we check on our images, like the outline. It's now everything filled. Now let's go back to mods. We can see here. Select PNG. Outline, open. You see now we have just like the inner line thing here. So when we calculate, it's just one line because we only have white one of the sides of the black line. Okay. So that's the other way of doing it. Like you see, like it needs more work than doing it with the terminal directly, but it's better to understand what we're doing here. So it's just like filling the different layers we want, and then like hiding and showing to export the image.
Okay. Questions, you guys?
Questions, you want anything, you want to add anything?
So the plugin that Oscar designed or wrote, it basically automates everything.
Exactly. It's the automation of all of that, but directly there. Exactly. And let's say here also you have a little bit more control. Okay, like let's compare what we get out from the images here, no? For example, into here we have FCU. Pero yo quiero el catch aquí, este. This one, for example, it's important. Like we need to make the line thicker on KiCad, because if not, we will have it the same. And here we have no option of making the all the outer part in black, for example. And also in the front cover, for example, here you have you will have the outline line. Let me open like this, it will show. So here we have this outline in black. So when you put it on mods, it will also make the cuts for the outline with the small end wheel. This is not bad for the PCB, but it will take more time. So you need to go faster. You can remove this line, and with those holes the same. No? Those through holes are through holes that you're gonna mill directly with the 1 divided 32 inches end mill. But if you keep it like that on the traces, with the 1 divided 64, it will take out the cover of the holes. You don't need to take it out because you will want to do it all the way. So this one, it's faster for creating the files and everything, but with the other one, you have a little bit more control, let's say.
I think that the important part here is to, at the beginning, especially that you work on let's say, the method, understanding everything, because it not only shows you control of the machine and all this stuff, but also you understand that not only is it control of the images, but also you get to understand a little bit how the machine needs to receive the input. You understand the coordinates, you understand all the things that Giuseppe was mentioning. And after that, you can compromise on things. After a lot of PCBs, I started doing this thing because for me it was too much time, and also the Instructor was working for me quite well. So I did that. But at the end, if you go into that repo, it's just a Python script that does it. So if you want to improve it, and maybe we can clean up these other comments, maybe we can make it perfect. But still, I think that for learning, it's better to do it this way, because you skip too many steps and you don't realize that then you just put the trust. Then you just trust one tool for doing everything for you, and you don't understand what's going on. So, well, with that, this is the whole workflow for this week. This is, let's say, design and file preparation. Now you know how to do, everything. With this material, you can start designing your PCBs and soldering and milling them and soldering. We're going before 2. I don't know if Edu is going to join for talking a little bit about the assignment and the objectives for this week.
I can do it if you want.
Okay, so Edu, Giuseppe is going to talk about that. For tomorrow, we're going to have a class a little bit going deeper into this for academy students, but of course, if MDev people also wants to come, you are more than invited. It's going to be about electronics components, a little bit more of design for electronics, and we're gonna keep talking about what we started talking some weeks ago for microcontrollers and processors and this type of things. So we keep building onto this path of electronics little by little. And for this, tomorrow we'll start at 11:30, because we have a team meeting in the morning for Fab Lab, and the class has to start at 11:30. Okay. Before that, we're not going to be available. And the class will be around 1 hour and a half or 2 hours. It won't be so hardcore as the other ones, but it will be a little bit more relaxed. And remember, it's at 11:30. Okay.
Okay, so for academic students, well, today with Neil, we're going to see the assignment. Really, this week assignment is to create what we call a hello board. That is just like a board with a microcontroller, an LED, and a button. Okay, you will see that in the academy, like in the academy webpage, in the schedule, you have like hello boards for the different chips the different microcontrollers we can use. Itty Tinies, HMD, ESP32, whatever. So we'll need to decide which one you want to use and create that board. So that board, it needs to include the microcontroller, the pins for programming it. So normally, depending on the microcontroller, you will need different pins to control it. LED and a button at least. Then you can put there whatever you want, but at least it has to have this. Okay. And then for MDEF, like the objective, like you don't have like a real assignment this week, let's say, but you will need to design some PCBs for your challenges. I don't know if it's for this one or for the next one. This like for the next one, but now that we are in this week that we're going to be like designing PCBs, I encourage you to design some PCB. Normally, what I will say you is, let me share my screen. Here. So I really, what I want you to do, like for this week, I ask you to practice a little bit. So for that, I would like you to try to do something like this that I did yesterday. It's just like a shield. So it's an extra board that you can connect on top of your feather board. So your user board that you have that is used for your electronics, you can just create a shield that is just a board that will be plugged onto your rear board, and you can have different things. No? Shield. No, for example, let's say in Arduino,
Más simple.
So you see here you have an Arduino, and this is a shield that is connected just on top of the Arduino, and you can have different components on top. So like this, you don't have to be playing with the breadboard every time. You have the shield itself. In that case, the shield I designed here, it was like just the holes for your trinket, and then like some traces with a button and an LED. Exactly the same that Academy needs to do. So I can upload this example on our webpage and try to replicate it, okay? But try to replicate it like creating it from scratch, so you learn how to use how the workflow goes and how to use KiCad and export the images, okay? And if you want, like you can come here and produce the boards. If you want to start milling and see how to design and produce these boards, please do it, because this is the week we're gonna be working on it, and you're gonna need to design some on different challenges. So I encourage you to start practicing now, okay? Doubt or I don't know who's talking.
Nice. What?
No, I said that it was a lot of information.
I cannot listen to you anything.
No, que es mucha información. Yes. I mean, yes. I mean, it's what it is. We could keep, I mean, yes, it's what it is.
And really, in the documentation of the page, you have like really like pretty step by step how to create the files. Okay, this is something that you will learn by practice. Like we can spend here like 5 hours working in examples, but it will not be useful if you do not practice learning. Like the way of learning this is to testing and like crashing yourself to the program. Like, it's the only way to learn it. Okay. We will be here, so if you need any help with it, like come and ask. But please try it yourself. Try to design the boards and see where you have problems.
Just one final comment here is that something we've been discussing about, let's say, requirements and, let's say, what we expect. So the Academy has very clear expectations. You have to design a board with at least a button and an LED. That's the minimum, okay? But you can go up to the limit wherever you want. But it needs to have that, and you need to be able to program it in the electronics programming week. Means that you have to put an interface for programming the board. You need to put power, connectors, and things like this. You have a lot of hello boards. So I think it's important that you know your expectations, you understand your limitations, and limitations in terms of time and, let's say, energy that you can put into learning, and that you, let's say, manage that. I think we're all adults here, and we can, let's say, manage that freely. And we only suggest we just give some advice, but everyone will go at its own pace. And it's important to accept that. Some people will go and design, I don't know, 3 Arduinos in this week. Some people will just put an LED and a button, and that's it. There's no problem there, okay? In the case of MDev, there's no minimum requirement now, but you will have a requirement in the next challenge for making this. And again, it's up to you. You can review this class, the recording, you can view some tutorials of KiCad, you can check this tutorial page, and those understanding your limitations with respect of time. We know that you have a lot of classes, we know that you have a lot of other projects that you have to do, and that making electronics is not the first priority for many, but it still is there. So just choose which path you want, and just remember that we are not here to demand things from you, but we are here to make you learn, and so that you, after some months, are able to make this project by your own and feel empowered. That's the main purpose of technology, not to be like criticizing or feeling, let's say, overwhelmed by it, okay? So it's a lot of information, yes, but it's good information, I think. Good? Any comments, questions? If not, I think we are sharp as hell, and we can go have lunch. Do you agree? Good. Let's go. Thank you.
The remotes, everything fine? Did you?
Yeah, okay. Thank you.
Perfect. Thank you very much. Let's check here.
See you.
Okay, see you.
Okay, thank you.
No, no, pero no, no, eso ya. Sí,
Voy a hacer lo mismo.
Regarding Monday's stuff, couldn't make it. I tried to connect on Zoom. The main. So getting the back end.
Will the same thing. Nothing I'm talking about the website, just the documentation, the information about what's going to be about the software. Because at the moment we just delete the yes, exactly there, and then you can just make just put it there, and then if you we decide how we want to do. You just put things there, and you say, oh, Andrea put this in here. Do we like it? Yeah, ¿Este ordenador? ¿Este?